Modern air filter cleaning is vital and a key component in the economic cost of running any machinery because filters are expensive to replace. But unclean and inefficient filters can result in massive increases in fuel bills and potential engine failure. The environment too can cop a lot of unnecessary pollution as a result of poorly cleaned filters. And we all know how the public and the EPA can respond to that. Fortunately, today's astute machinery operators are careful to balance the needs of air filter reliability and effectiveness against replacing with new filters or over-servicing by having their filters cleaned on a regular basis. Hi there. As you'd know, there are two principal methods of cleaning filters: the superior wet cleaning method and air dry cleaning. This video will show you why wet cleaning is without doubt the best, both for engine efficiency and running costs. But first, let's have a look at what the filter manufacturers themselves have to say about air filter cleaning. After all, they have the technical knowledge and a vast experience in filter technology. A leading European company many years ago was amongst the first to develop a set of instructions on air filter wet cleaning, which has remained unchanged to today. Donaldson, Baldwin and Wicks, all renowned manufacturers, have air filter cleaning kits available and a set of instructions that clearly indicates how to wash filter media itself. The key point here is that none of these manufacturers recommend air cleaning other than 30 psi maximum blowout of external contaminants from inside to out. This is because if higher pressures are used, then it's likely that instead of removing contaminants, they concentrate deeper and become embedded into the filter media itself, rendering that area ineffective. It is true that low-pressure air blowout will give short-term relief, but merely because some of the outer surface contaminants have been removed. But it is a fact that high-pressure air streams used in air dry cleaning methods can in fact damage the filter media itself, as well as the built-in sealing structures which are there to seal and retain the filter media. This brings up a key point. How does one guarantee a filter's sealing structures are intact, so the contaminants cannot directly enter the engine by passing the filter media with potential catastrophic results? The only true way of guaranteeing an air seal is to make sure that air can only enter the engine through the filter media and not through a hole that can't be seen. Air dry cleaners would have you believe that by shining a powerful light from inside a filter, you would be able to see holes. But, as you can see from this illustration, a modern filter is air sealed in a convoluted fashion, and because light travels in a straight line, you may not have any visible indication of holes or defects. The reality is, the only way of assuring a proper seal is to immerse the filter into liquid and test for air bubbles. This is precisely what Fleetguard engineers found when they went looking for the most secure method to find holes. Other filter manufacturers also know this, and they have all manufactured their filters to not only cope with liquids, but in fact, as you'll see later, significantly benefit from wet cleaning. Testing for holes is simple using this modern machine in which the filter is sealed at each end and lightly pressurized. Any holes are clearly seen by bubbles of air leaking out, which clearly shows the filter to be defective. The whole point about checking for holes is that there's little point in cleaning a filter if it's been damaged already. Air dry cleaners check for holes by light, which is clearly unable to detect all but the most obvious holes. Unfortunately, should you use air dry clean filters, you are running the risk of serious engine failure. Earlier we said that wet cleaning is without doubt the best, both for efficiency and total running cost. Let's now take a look at how wet cleaning achieves that. Firstly, when filters are delivered, they're given a careful visual check to make sure the filter structures are intact and undamaged. For example, bent covers and liners. At this point, they are pre-washed to remove the rest of the surface contaminants. Filters are now soaked in a specific detergent, which is constantly circulated to loosen and dissolve even the most stubborn of contaminants. Microscopically, you can see this in action. First, the individual contaminant particles are loosened and then dissolved away by the detergent. The key point here is that unlike air dry cleaners blasting, which tries to dislodge particles, wet washing in detergent actually dissolves the particles, leaving the filter media clean and undamaged. Wet cleaned filters are then soaked in the detergent, washed and rinsed thoroughly with fresh clean water to remove traces of both detergent and contaminants. Low-speed spin drying follows to remove any excess water. Then the now clean filters are air dried in a temperature-controlled environment which circulates hot air through and around the filters. Once returned to room temperature, the filters are individually sealed in plastic, ready to be put back to efficient work once again. Filter cleaning isn't rocket science, but sometimes a few facts and figures along with good, honest laboratory tests can really show just how efficient and cost-effective wet cleaning is. On the left, this FleetGuard-based chart shows tests conducted on AF879 filters, which were contaminated, resulting in some poor results. Compare this with the right-hand independent wet cleaning test chart, showing superior results. After a mere 2 cleans, the air dry filters lost 10% of their capacity, and by 5 cleans, the filter's capacity had dropped by a massive 31%. On the other hand, wet cleaning results show that the filter capacity had dropped just over 10% after an amazing 10 cleanings. Side by side, the results show that there was a massive capacity loss associated with air dry cleaning compared to the superior wet cleaning method. Simply looking at the 2 filters clearly shows the difference. Air dry cleaners would have you believe that the dirty look is a special pre-coating. The fact is the filter is dirty because the contaminants are still embedded in the filter media. In some markets, like the Hunter Valley coalfields, the differences are even more noticeable, simply because coal dust in the air is greasy and is embedded or soaks into the filter, and the only way to eliminate it is to wet clean the media. Further laboratory tests were conducted by Newcastle University to back up the FleetGuard findings. John Wanders is the laboratory manager in the Chemical Engineering Department. Here's what he had to say.
In actual fact, the testing that was carried out within this university involved laser particle sizing techniques and electron microscopy. These electron micrographs show that the process of wet cleaning removes more of the retained particles than by using dry cleaning methods. The results speak for themselves.
In these electron microscope pictures, you can clearly see the significant advantage of a 4 times wet clean filter sample over a 4 times air clean sample. Visually, the dry clean sample is massively blocked in comparison to the wet clean sample. Therefore, a wet clean filter has a far greater economic life. These University of Newcastle tests only looked at the effectiveness of the filter cleaning, but what operators really need to be aware of is that filter integrity and lack of air leaks must be guaranteed, as with the wet cleaning and testing method, because of the high risk of premature engine failure. In summing up the advantages of wet cleaning, 4 things are very clear. Unlike high-pressure air dry cleaning, wet cleaning removes contaminants by dissolving them away. Wet cleaning is gentle on filter media and doesn't run the risk of damaging either the media nor its supporting mechanisms, which cannot be said for high-pressure air blasting. Field and laboratory tests clearly show wet cleaning's superior efficiency, which leads to cost-effectiveness. And finally, wet testing really is the only risk-free way to assure that there are no holes or leaks in the filter. To say that merely blowing high-pressure air over a filter to clean it defies logic. The filter manufacturers are clear and concise. They say that wet cleaning is the only safe and effective way to ensure longer economic filter life. We say your bottom line and the environment are our first criteria. Wet filter cleaning can and does deliver environmentally friendly cost savings to you, free of risk.